Hello everyone, and welcome to the EsmaCAT 16 channel analog input tutorial for differential inputs. In this video, we will demonstrate how to read differential analog input signals by using the EsmaCAT system. The EsmaCAT 16 channel analog input is an EtherCAT based analog input voltage interface. It can read 16 single-ended or 8 differential inputs with various programmable ranges. Here, we would like to demonstrate the reading of a differential input. Now, let's get started. In order to read analog voltage inputs, we need several EsmaCAT components. First, we need one EsmaCAT master device. In this tutorial, we will use the dedicated EsmaCAT server S as our master, but any Windows or Linux machine can be used as the EsmaCAT master by downloading the EsmaCAT server software from esmacat.com. Second, we have to prepare one EsmaCAT slave set. This set consists of the EsmaCAT 16-channel analog input, which we will connect to a breadboard circuit to demonstrate the reading of differential inputs. In this tutorial, we are going to use an external power supply as the voltage source. The EsmaCAT master and slave set will be connected to each other and communicate via the EsmaCAT PoE, or Power over EtherCAT. This enables our master to provide both communication and logic power to the slave over a single Ethernet or RJ45 cable. Here is the breadboard circuit that we shall use. This is a standard simple voltage divider with multiple resistors in series. The schematic of this circuit is shown on the top right. This circuit consists of 4 1 kilo ohm resistors in series, and 24 volt DC is supplied by the external power source. We will measure 4 differential voltage input pairs between node 1 to 4 and node 0. Now, the hardware setup. All wires from the breadboard circuit to measure voltage at each node will be plugged in from channel 0 to channel 7. On the right, we have the PoE system that was discussed earlier. Now, let's write out our code together. We can start with the template that is included in the EsmaCAT server software development kit. Let's open the header file. We need to create one object for EsmaCAT slave to represent the type of slave that we wish to physically use. Under private, we create a pointer to EsmaCAT analog input object. Next, let's look at the source file. In the connect function, our declared object needs to be connected with the actual EsmaCAT slave. The function, named as assign EsmaCAT slave index, is for this connection. Because the analog input board is the first, and in this case the only, slave connected to the EsmaCAT master, let's assign our object ECAT-AI the index of 0. Let's move on to the setup function. Because the analog input board can read 2 different types and various ranges of signal, we need to set options for input channels to acquire proper inputs based on our purpose. For this, let's declare analog input option objects first. After declaring the option object, we can set analog input configurations. The 16 channels are grouped into sets of 4, each with an assigned variable in the EsmaCAT analog input object. The user can set types and ranges of input signals that each group of channels can read by using this object. In this tutorial, we will set the parameter to read from -24 to +24 volts because our measured voltage is in the 0 to 24 volt range. Last, we push this configuration object to ECAT-AI using a setSystemParam function. Our setup function is now complete. In the loop function, we will write a line to print out the elapsed time and a for loop to print the differential voltage input in channels 0 to 7. This is to output the measured voltage to our screen as a demonstration. And now to demonstrate. In this case, we see the time on the leftmost column, followed by the index and values read by all 8 input channels. Note that since we are reading differential inputs across a pair of channels, both channels in the pair will display identical values, which represent the difference in voltage between them. Thank you for watching. For more information and tutorials, visit our website, EsmaCAT.com, and our YouTube channel, EsmaCAT.